At some point, you start solving systems of linear equations using the addition-elimination method, but you get into harder questions like this one right here. In this case, there's no easy way to multiply one of the equations so the coefficients cancel each other out. But we don't need to be limited to multiplying one equation by a constant in order to change the coefficients. We can multiply both of them. In this case right here, what I'm going to choose to do is to attack the x's. I could do the y's in a very similar fashion, but I'm going to make the x coefficients opposites of each other. The way that I'm going to do this is I'm going to multiply the first equation by 5, and I'm going to multiply the second equation by -3. The important thing here is I want to make one of these coefficients a 15 and the other one a -15. When I multiply the first equation by 5, I'll result in -15x plus 25y equals -70. When I multiply the second equation by a -3, what I'll get is a 15x. Importantly, this is the reason I'm multiplying by -3. -3 times -5 is a positive 15. These x's are now going to be eliminated when I add these two equations together. -3 times the positive 4y is a -12y, and the -3 times -19 is a positive 57. Whenever I'm doing this, if I have to multiply both equations by a constant to get the coefficients to cancel each other out, it's important to realize all I need to do, generally speaking, is multiply them by each other. In this case, I have a 5 and a 3. I'm ignoring signs for half a second. If I multiply this by a 5 and this by 3, I know then they'll be the same coefficient. The only thing I need to adjust is maybe making one of them negative and one of them positive in order to get opposites right here. Adding these two equations together, -15x and positive 15x cancel each other out. Plus 25y minus 12y is 13y, and the -70 plus a positive 57 is a -13. Divide both sides by 13 to get y equals a -1. As always, I need to plug this value for y into one of the original equations. I'll use the first equation and I'll solve it for x. This will give me -3x minus 5 is -14. I'll add 5 to both sides of this equation to get -9 here, and then divide by -3 to get x equals 3. This will give me a solution to my system of linear equations of x equals -3 and y equals -1. Again, just to remind you, you can multiply both equations by a constant in order to get the coefficients to cancel each other out, or the terms to cancel each other out because the coefficients are opposites. In this case, the -15 and the positive 15. One very simple way of doing this is to recognize if I multiply the 3 by a 5 and the 5 by a 3, they'll both be 15. The only thing I need to negotiate is one of them needs to be a negative and one of them needs to be a positive in order for the terms to cancel each other out when I add the equations together.